think
How about now? Yep. Okay. Sorry about that. Let's flicked a button, maybe.
Yeah.
Is that okay? So this would be considered a biosignature, or a strong biosignature, and there'll be many people saying that we've probably discovered alien life. So this is a possibility, and we don't know how long it will be before we find this, but most people expect we'll find it eventually. Now, there's a problem of unconceived alternatives here. There would be no known abiotic explanation of that signature. But I mean, there's a lot of discussion, certainly in philosophy of science, about the problem of unconceived alternatives. This is a situation that's cropped up many, many times in the history of science where there's been an unconceived alternative. And people have got excited about something or favored a hypothesis or a theory potentially for a very long time, but only because they were unaware of some alternative that was better. And Kyle Stanford, in this book, Exceeding Our Grasp, Science History and the Problem of Unconceived Alternatives, he tries to sort of persuade us in this book that many, many times in the history of science, there's been a front runner theory, and people were tempted to believe the theory was true, and then a better theory came along at a later time. There've been lots of examples of this applied to potential biosignatures already. There've been many phenomena where at one time there was no known abiotic explanation of that phenomenon, and then later on an abiotic explanation was developed. Not only that, but then the abiotic explanation was preferred, and people said maybe we shouldn't have got so excited that we had discovered extraterrestrial life. Or in this case, this was to do with life on Earth. This is just one example of many that I could give you, but I don't have much time. So this is 2016. Rapid emergence of life shown by these phenomena. 2018. Reassessing evidence of life. Here we report a non-biological origin for the structures. So this is a typical pattern, really, that we've experienced. And I won't really give you any other examples, except to mention oxygen that would have one time been called a biosignature. And then at a later time, people developed plausible abiotic explanations for accumulation of oxygen in the atmosphere of an exoplanet. So if we now found oxygen in the atmosphere of an exoplanet, there would be much caution because we have plausible abiotic explanations. Whereas at one time, we didn't have that. But an oxygen-methane disequilibrium, we can't currently conceive of any plausible abiotic mechanism for such a disequilibrium. Do we then infer highly likely the disequilibrium has a biotic cause? There's a temptation to do so. Past examples seem to show that we scientists think, are tempted to make this inference. There's this recent paper published by a team at NASA in Nature trying to develop a confidence of life detection scale, because they think that we're at a time when we're starting to get these phenomena coming in, and we want to be able to say, where are we on this scale of how confident we are, where at one extreme of the scale, we know we've found extraterrestrial life, and here, we've just got an interesting signal maybe, but no one's getting excited yet. They have this interesting stage level 4, all known non-biological sources of signals shown to be implausible in that environment. The thing about that is it depends on how much work we've done to look at possible non-biological sources. And I think it's controversial. One thing I want to say in this talk is that it's controversial to have this at level 4, because that's sort of halfway to this stage where we're getting where we've actually sure we've found life. But the fact that all known non-biological sources are shown to be implausible in that environment might not mean much if we haven't actually done much exploration of possible non-biological explanations. Or if, based on past cases, we should expect that probably an abiotic explanation will be developed in the future. So if the case is like this is sort of the possibility space, the space we're trying to explore or consider here. If we've explored a lot of it, then we can maybe start to get excited that there's no known abiotic explanation. If instead we've explored this much of the space, then we shouldn't start getting excited, because we've only just started thinking about possible abiotic explanations. And I think there's good reason to believe that in astrobiology and in the context of biosignature research, it looks more like this. In this paper from 2021, False Biosignatures on Mars Anticipating Ambiguity, McMahon and Cosmidis, right? This area of inquiry has received rather scant and unsystematic attention from astrobiologists who've tended to focus their published work on expanding our knowledge on life signatures rather than its abiotic mimics. So they go through various examples of abiotic mimics, abiotic phenomena which present signals which look a bit like what you would expect from life. Given the haphazard and unsystematic way in which varieties of false biosignature have so far been identified, we can only assume that many others remain undiscovered. So this is just to give you a sense of, I think, a very reasonable point that we've only just started exploring this possibility space, meaning that if there's no known abiotic explanation, that doesn't mean very much. So I've been thinking about how to quantify the extent to which a possibility space has been explored, because it seems like you need to factor that in if you're asking yourself about the uncertainty quantification in this kind of context. There have been and this is something I'm interested to get your feedback on, or your thoughts. How do we identify possibility space and quantify the extent to which we've explored that space? Okay, there's lots of examples of people trying to do this kind of thing. This is just one example I've come across recently. The limits for life under multiple extremes. So what are the limits for life? Well, let's consider pressure, pH, and temperature. Interestingly, this graph doesn't give you the limits for life under these extremes. It just tells you what we've explored so far. So instead of giving you the limits for life, this tells you more about just the limits of our exploration of the space. What I'm imagining is something like this for research into abiotic mimics, which would then you could come up with some kind of judgment of the extent to which we've explored that space. And if we've explored it a lot, then you could get excited about the fact that we've found some phenomenon for which there is no known abiotic cause. At the extreme, if you've completely explored the space, you know it's life. when you get that signature, if there's still no known abiotic cause. We thought a bit about Bayes' theorem and its possible use of Bayes' theorem to help quantify the relevant uncertainties, and it doesn't seem helpful because how on earth to fill in the probability of the evidence given not life? So this is the probability that you would get that signature from an abiotic cause, basically. That's what this term is, and you need to be able to fill that in. If you haven't done the research yet to explore that possibility space, then you ought to say, we just don't know, we haven't done the research. You can't put a value on that probability. And at that point, it seems that the Bayes formula doesn't help you at all in trying to quantify the relevant uncertainty. So I think there's a conflict between what would happen if we discovered an oxygen-methane disequilibrium in terms of the excitement and the sober assessment of the relevant uncertainties would suggest. So this is a bit of a boring talk. I'm saying, don't get excited about the possibility of alien life anytime soon, even if it's all over the headlines, which it probably would be. So I mean, this inference would certainly be made by journalists. We can't currently conceive of any plausible abiotic mechanism for X. Highly likely X has a biotic cause. So we're trying to write a response to this paper that came out about confidence of life detection scale, and in particular this level 4 here, where level 4 is actually hugely significant if we've thoroughly explored the possibility space. In fact, at the extreme of exploring the possibility space, at level 4, we know we've found life. If we've only just started exploring the possibility space, level 4 basically means nothing. We shouldn't even start to get excited yet. So, reaching level 4 is compatible with really the two extremes of the scale. So we don't think that this is the right way to quantify our confidence of life detection, as they put it. This is what I've just said. So the take-home message is quantifying uncertainty and assessment of possible exoplanet biosignatures requires quantifying the extent to which we've explored the possibility space of abiotic mimics. We're only just starting to think about how you would try to quantify that. I'm just trying to get examples from other areas where in order to try and quantify one's confidence in something, one has had to come up with some kind of judgment about the extent to which the relevant space has been explored. And obviously we all have intuitions. In the case of astrobiology, there's an intuition that it's still a young field. So the early days of exploring abiotic mimics. There's no sort of number you can put on that, it would seem. In other contexts, we're confident that we've thoroughly explored a possibility space. But if anybody has any more sort of rigorous approaches to quantifying the extent to which a possibility space has been explored, then I'd love to hear about them. Okay, that's all I have to say.
So outside of films, aliens has not really come across my research base before, but it sounds very much like you're talking about quantifying unknown unknowns, which I think a lot of us have probably attempted to do, and debunk things like Italian flags along the way. It's always worth a look at that white space and how big that white space might be. Does anyone have any comments or questions?
Oh, not that established. David Sexton, Met Office. I was sitting there and I was wondering about climate change, anthropogenic climate change. And it's the alternatives that you talk about here. So, I mean, clearly we use computer models to demonstrate, what counterfactuals, and without any anthropogenic forcing, we wouldn't have got the temperature record. We look at the time scales that the warming's happened over, and you can't explain it. But that I just, considering all the things I've heard about in the last like 30 years, and like the solar cycle was, or solar influence was really something that people looked at. So they were looking at different ways in which you could amplify the solar forcing. So there were I remember the Danish scientists coming out with sort of correlations between clouds and solar physics, and it just turned out that they just happened to alias. There were missing gaps in the data record, and they just kind of come up with correlations, and that wasn't very robust. But I've heard all sorts of things from volcanoes affecting it, volcanoes and the solar being linked together. There's a whole bunch of, if you looked, that there is a whole area of stuff that people have considered and have been kind of debunked over time.
Yeah.
But you know, like the evidence is still, I mean, it's really strong, but it's not, it's still, you know, it's still not nailed on. There's still a small pop chance, but we've made, I think the other point is we've made predictions with on other variables, and it's not just one variable that's we're using to detect it. We're using spatial patterns and other variables, which I think gives you more confidence. It's more evidence, which was, I think, your point 5, level 5 or level 6 in that chart, and that helps a lot.
Yeah, I think in a lot of these cases, the evidence is very thin. You can't come at it from many different angles. We're getting better at it, but yeah, I like that example. So you're presenting that as a case where a possibility space was with time thoroughly explored. That's what you're suggesting. Yeah.
There's a whole bunch of scientists out there looking at it from all sorts of angles. Some of the first well, they came up with what they thought was thought space. Other people have ruled them out. But yeah, you see a number of people that
Yeah, I think we have actually been looking at the global warming case as a good case for lessons to learn from, including uncertainty quantification. But I think in that case, there's something to be gained from, like, you can measure the consensus of a community about something. And people have done this thoroughly with the case of anthropogenic climate change. It's probably the most thoroughly thing that's ever been, where community opinion has been quantified. So it's usually 97, 98%, right? That was a rubbish community. Yeah, I think that one thing you could do to try and measure the extent to which a possibility space has been explored is ask the community, which is obviously a difficult thing to do, but the community opinion is so much more important than the community of any individual within it. And there are methods that we have now to try to make sense of the fact that a community has an opinion, or there's a consensus of such and such a strength. And I think that would be a much better guide in the case of astrobiology as to, have we discovered aliens? Just you could have a confidence of life detection, which simply is defined by the strength of the community opinion, rather than trying to put these in the way that the NASA team has tried to put these more fine-grained steps along the way to do with the specific evidential situation. Yeah, I can see that. Yeah, sure. Yeah.
Important to look across community as well. I think one of the benefits from climate change is you've got, you know, different kinds of scientists all pointing to the same thing. Whereas if you just have mathematicians or you just have chemists, if you can find kind of a completely perpendicular test that isn't related and also meets that also you can't find another abiotic explanation to, then that really helps. Whereas if it's something linked, then you haven't got anything. Trying to figure that out.
Yeah.
We're getting to the end, past the end of the day, and I know people have very busy lives, so I don't want to do that. Yeah.
I'll perhaps say thank you on your behalf to all the speakers, our brilliant speakers today, and thank you for being such a fantastic chair. And just to thank our virtual participants. This is just a notice for our physical ones to remind you that dinner is at Westminster College at 7 o'clock, which means they'll be bringing the food out at about 7. So maybe see you there just before 7 o'clock.
In terms of colleges, are there any like thou must wear a tie?
It's smart casual, and I would say please wear your face mask going around there until you sit down. You know, obviously.